All right, so we just talked about how limits can approach negative or positive infinity, and we discussed that this equal sign um, is not exactly true, but mathematicians understand that it's implied that since infinity is not an actual number, it's a concept, that this is actually an undefined limit. But for the sake of some algebra we'll do later, we're going to say that they're equal. And that's just what this talks about right here. So although we may write that an infinite limit is equal to positive or negative infinity, this still tells us that the limit fails to exist. So that's important to remember. I don't want you to ever think that this limit actually exists, because it does not. It's increasing or decreasing without bound. So now let's take a look at a couple more examples. If you understood the first one I did, these are going to be really, really easy. If you look here, I've already sketched out these graphs, so you might want to pause the video and sketch them yourself. With this function, we can see that there's going to be a vertical asymptote at x equals 1, because that creates a 0 in the denominator. We'll talk more about that in a minute if that doesn't make sense. And the same thing over here, vertical asymptote, because 1 would create a 0 in the denominator. What we want to do here is talk about the limit as we approach that value. Now, if we just say what's the limit as we approach 1, then we would say undefined. But if we only look at it from the left or the right, we can be a bit more specific. So first of all, let's do the limit of f of x as x approaches 1 from the left. Well, just like in the previous example, we're going to come in from the left. We can see it's increasing without bound, which means we're talking about positive infinity. And then we'll do the same thing from the right. The limit of f of x as x approaches 1 from the right equals, and then we take a look at the graph. We come in from the right, and we're increasing without bound, so again, positive infinity. Keep in mind that the limit still does not exist technically. But that's it. Those would be the two limits. Now let's look at this graph. So we can see these are increasing and decreasing without bound, so we're going to have two different infinite limits. The limit of f of x as x approaches 1 from the left is going to increase without bound, and therefore be positive infinity. And then the limit of f of x as x approaches 1 from the right, we come in on our graph from the right, we can see that it's decreasing without bound, and so that's equal to negative infinity. Now I will tell you that it is very difficult, if not impossible, to determine infinite limits without having a graph. So your graphing calculator is going to be your best friend. If they ask you to find an infinite limit, you're going to know it's an infinite limit because you can't plug in your C value. You can't plug in chug, but if you can't plug in chug, then you need to have a graphing utility to help you analyze that. And we'll do that a lot in class. Now let's kind of shift gears and talk about vertical asymptotes.